In the name of Allah, who is most beneficent and most merciful. Welcome to Dr. Hassan Mathematics channel, ninth class Mathematics, chapter number 1, exercise 1.2. This exercise, first three questions solved in last lecture. You will listen carefully, and other three questions solved in this lecture. Question number 4 is find negative of matrices A, B, C, D, and E. Matrices A is 1 0 minus 1, only one column. These are called column matrices. Apply negative sign, positive entry change into negative, and negative entry change into positive. Minus 1, positive 1 is change into minus 1, 0 is neutral, negative 1 change into positive 1. Similarly, matrices B 3 minus 1 2 1. Apply negative sign. After apply negative sign, positive 3 change into minus 3, minus 1 change into positive 1 similarly. Matrices C, its entries 2, 6, 3, 2. Apply negative sign. These are called positive all entries. After apply negative sign, change into negative. Only sign is changed in negative matrices. Matrices D, minus 3, 2, minus 4, 5. Apply negative sign. Minus 3 change into positive, positive 2 change into negative, minus 4 change into positive 4, positive 5 change into minus 5. Similarly, matrices E 1 minus 5 2 3. Apply negative sign, change into positive 1 change into minus 1, minus 5 change into positive 5. These 2 and 3 positive change into negative. We find our negative matrices. Any matrices change into sign, positive entry change into negative. These are called negative matrices. Question number 5 is find the transpose of matrices. Column change into rows and rows change into columns of any matrices is called a transpose of matrices. You will your choice column change into row or row change into column. First matrix is A is 0 1 minus 2, only one column. We take a transpose, change into row 0 minus 0 1 minus 2, change into row 0 1 minus 2, find a transpose. Similarly, matrices B 5 1 minus 6, we take a transpose, only one row, change into column 5 1 minus 6. Matrices C 1 2 2 minus 1 3 0. It's 3 rows and 2 columns. We take a transpose. First column is 1 2 3. First column change into row 1 2 3, it's row. And second column 2 minus 1 0 change into row, 2 minus 1 0 change into row. You will your choice column change into row or row change into column. These answer will be same. Similarly, matrices D 2 3 0 5. We take a transpose 2 3 2 0 is the first column change into row 2 0, and 3 5 is the second column change into row 3 5. Matrices F is 1 2 3 4. It's 2 rows and 2 columns. These are called square matrices. We take a transpose. 1 3 is first column change into row. 2 4 is second column change into row 2 4. Matrices E is 2 3 minus 4 5. We take a transpose. 2 4 is the first column change into row, 3 5 is the second column change into row 3 5. In transpose of matrices, not change a sign, only rows change into column or column change into rows is called a transpose of matrices. Question number 6 is verify that if matrices A is given and matrices B is given. We will verify A transpose and its again transpose is equal matrices A. And second part is B transpose and its again transpose is equal to these matrices B. First we solve this. We take a matrix as A 1 2 0 1 is a scalar matrices. We take transpose rows change into column or column change into row. Similarly, last question 1 0 is column change into row and 2 1 second column change into row. Again transpose of this matrices. Again mean double transpose. We take a transpose again this matrices is 1 0 is a row change into column 1 0 and 2 1 is a row change into column 2 1. These matrices equal matrices A. We will write matrices A and hence proved A transpose and its again transpose equal matrices A. It's proved. Similarly, matrices B we take and we take its transpose. 1 1 is first row change into columns, 2 0 is second row change into column. Again transpose of this matrices. We take transpose 1 1 is first column change into row, 2 1 is 2 0 is second column change into row. These matrices equal again matrices B. Hence proved B transpose and its again transpose equal matrices B. Hence proved. We will verify these and we will verify it and hence proved it. We will meet in the next lecture and we'll study about addition and subtraction of matrices. Thank you.